Hello and welcome to session 3. This is autonomy and the connected infrastructure. So it's what's the industry doing now to get ready to connect up to the infrastructure that we've already got, and what needs to happen so that we can connect up this new technology with the world that we live in at the moment. 4 fantastic guests. I'll introduce them in a second, but first a little bit of housekeeping for you. So if you have any questions, and we've had brilliant questions in all morning, and you can like them as well, and the most popular ones I will try to read out, but please use the Q&A tab on the right hand side of the window. Click the show in pop-out on the bottom left of this window if you'd like to visit other pages on the platform whilst listening to the session. And also quite a few people that have been doing the competition as well, and there's vouchers to be won. We'll be announcing that at 4 o'clock, so chip in there and you could get a nice early Christmas present. But first of all, let me introduce our 4 fantastic panelists for this session. So we've got Maya Pindeas, who's CEO at Humanizing Autonomy. I'll tell you a bit about her. They use deep machine learning to work out how humans and machines should interact. It's more about machines getting used to humans than the other way around. And developed an art installation, I've seen the video as well, that involved a robot putting on your makeup. So it was kind of carnage, Maya, wasn't it? But a great video. Puts everything in perspective. Mark West was the Chief Technology Officer of Connected Places Catapult. He worked in the defense sector on drones, then moved on to civil. And the biggest question when we were chatting the other day, Mark, you were saying was, how does the UK grab the big slice of the fund and the money that's going to come through from this fantastic technology? How do we make sure that we basically use this to boost our economy? Critical question. We'll get your thoughts on that later. Mike Potts, CEO and co-founder of Street Drone. So they will basically make you a fully functioning, complete, autonomous, affordable vehicle for your research. So they're, for example, making them for universities. And Mike, I think, do you supply the safety driver training too? Is that right?
Yep, absolutely. Yep, everything end to end.
And then we've got Paul Clark, who until very recently, very recently, was the Chief Technology Officer of Ocado Group. He's involved in lots of other things as well. He was telling me he was in a meeting with Grant Shapps very recently talking about the future. And also we've decided has the most interesting backdrop because it looks like a real inventor's room you've got there, Paul.
Yeah.
So we'll get little 5-minute chats from all of them about what they're up to, and then we will go to the questions, get those questions coming in now. But first of all, let's start off with you, Maya.
Yeah, thanks a lot. Well, you know, we started Humanizing Autonomy a few years back with a strong conviction that what the world really needs in order for automation to succeed is a global standard that enables any machine to interact around people, to really interact with people. So what that means is that we believe in providing technology that helps automated systems. And by automated system, I mean any system that has a vision-based sensor, meaning a camera, and any type of processing availabilities, as small as a mobile chip, to understand and predict what people are doing, what everyone is doing in the scene, what people are likely to do. So essentially capturing the full range of human actions into an intent prediction engine that runs real time on the edge. And the edge component is really important because what we really want is to create a fluent interaction that allows safe deployment, that allows efficient deployment, and allows really a pleasant coexistence and trust between people and machine. The way we do this is that we focus heavily on the urban mobility systems, on the urban mobility sector, where we feed this vision-based technology into existing and new systems. So that may mean, for instance, we work with dash cams, for instance. We power dash cams that can be plugged into any type of existing fleet vehicle to provide advanced hazard perception, allow drivers to be safer, to prevent accident, to reduce accidents, and at the same time work with smart infrastructure cameras, make sure that public junctions are safe, that we governments and municipalities are able to achieve the Vision Zero goals, but also power production vehicle systems such as driver assistance systems all the way up to autonomous vehicles, meaning that it really is around providing a horizontal intent prediction layer that draws from vision, draws from camera, fits on any mobile chip, any chip you can find on your mobile phones today, and with that creates interaction. And that really is what, in our view, makes widespread automation stagnate, really. We've seen a lot of progress over the last few years when it comes to higher levels of automation, but even assistive systems to help, let's say, drivers or pedestrians be safe in an urban environment. But we failed to see large-scale adoption. And that's widely due to systems, technology systems, not being able to cope with, what often is called an edge case, but actually is what is ubiquitous, us people, roaming the streets and actually interacting with vehicles, interacting with machine systems. And that's really what we're here to solve. We believe that once an automated vehicle is able to really drive through central London, once a driver assistance system is able to, again, roam through heavily pedestrianized environments, providing an experience that actually complements and helps driver, passengers, and pedestrians alike, this is where we'll see the breakthrough of large-scale automation. Thank you.
Thanks, Maya. I think it's really interesting, actually. We've got a bit of a stalling there of that interaction and what we can do to kickstart it. I know, obviously, something you're heavily involved with. Mark, over to you.
Thanks, Richard. Just in case anybody missed the introduction that my colleague Neil Fulton did earlier, just to say a little bit about the Catapult. Connected Places Catapult is one of 9 catapult centres in the UK. And we're the UK's innovation accelerator for cities, transport and places. And we're an independent non-for-profit organisation. We're focused on growing UK jobs and companies through innovation. And obviously our focus is on new technology related market opportunities, autonomy being a really important one of those. So we're active in exploring opportunities for autonomy across a wide range of surface transport and aviation domains. We're probably best known for our work in the drones and the connected autonomous vehicle sectors. And if we think about connected autonomous vehicles for a second and our sort of journey through that, it started back in 2014 with the Deluxe Pathfinder vehicle that we worked on with other partners, and that put the first public demonstration of an autonomous vehicle in a public place. Now, since then, we've progressed through much more ambitious technology demonstration, again with working across both the academic and industrial sectors in the UK, and in parallel worked on the safety and regulatory work that's required to open this market up. And probably the recent highlight of that journey that the Catapult's been involved in would be the Human Drive project, which was done with partners like Nissan, Hitachi, University of Leeds and Cranfield. And that saw a 230-mile demonstration of an autonomous journey from Cranfield to Sunderland. So quite an achievement, from a technology perspective, great progress. And it's secured the investment of organisations like Nissan and Hitachi into the UK for follow-on R&D. So that's a really big win. In terms of where we are with CAVs now, I think probably my perspective is that what we now know is that it's a hard journey, and the path to commercial revenue in road vehicles is probably technically harder, and it's going to take longer than we thought it would have done 5 years ago. And therefore, I think what I'm really interested in thinking through are thinking much harder about what the near-term opportunities for autonomy are in different applications. So how can we use automation in more controlled environments, and how can we align that with commercial benefits? And I think this should be very strongly use case driven, so that we have a roadmap of use cases which takes us from where we are today and provides a revenue stream for the new innovators in this space, such that we don't lose the opportunity that's been invested in already. And for example, use cases, some of the things we need to think about, I believe, are applications where we can control the environment, we can make the automation or autonomy task simpler, and applications where we can reduce the speed and reduce risk in particular situations. So we might think about applications like low speed vehicle deployment on campuses where we can control the environment to some extent. We might think about, let's think about an airport and all the different airside operations that go on with things like baggage handling, for instance. Or we might think about the first and last mile logistics opportunities. And obviously the previous sessions, you'll have heard something around that from organisations like Starship. I think we need to be very active in the practical experimentation of these technologies. And we might look at the recent announcements around the government R&D roadmap and in the increase in government investment. And I think as a community, we need to see that targeted, particularly at the D end of the R&D, the practical experimentation, as well as the fundamental research. And I think, platforms like Street Drone that Mike will talk about, provide an excellent mechanism for doing that. And also we need to think about the surrounding infrastructure. So we're partway through a rollout of 5G technology, for example, at the moment. The small cell part of 5G hasn't really taken off yet, but how can we use this technology to support some of these automation cases? Can we use that smart infrastructure to remove some of the autonomy burden from the vehicle? And there's an opportunity here, I think, to create a global standard for the infrastructure ecosystem that supports these use cases. Another question could be, can we build on the recent government investment in the OneWeb satellite constellation? And I think fundamentally it's how do we carry on the momentum that's been built up in this sector and make sure that we develop a really valuable supply chain here in the UK with global potential.
Thanks, Mark. It's interesting, actually. Have we got a bit seduced by, the stuff that looks fantastic on tomorrow's world and on the news, people driving around quickly on motorways, and actually should be focusing more on the stuff that's practical and possible and building up to the more complex stuff. Mike.
Good afternoon, everyone. I couldn't agree more with Mark, actually. I think we have to get our heads out of thinking about autonomy as something that's very applicable to passenger vehicles, and it's going to be ubiquitous really soon to thinking about how you apply lower speed autonomy to services that people can really benefit from. So a lot of the work that we do is really focused on exactly that. The vehicles you can see behind me here are the first vehicle we ever converted to be autonomous, and we're one of the only places you can go and buy an autonomous vehicle and have that run on the road. And we kind of came at this problem from three different directions. One was, how do you make an existing vehicle safe when you fit it with technology to make it drive? Because most of the vehicles out there that are autonomous are retrofitted, so they're either trucks or they're existing road vehicles that have been made to drive autonomously rather than being designed to drive autonomously. So the first thing we did was create a very safe retrofit drive-by-wire kit that can go on any particular vehicle. So you could even autonomize a sports car or something like that, or a tank or a bus or whatever you wanted to. That was the first problem. The second one was, obviously everyone knows it costs an awful lot of money to develop the software itself to drive on the road. And most companies don't have hundreds of millions of pounds to spend on that kind of development. So we joined an open source consortium called AutoWare, and then eventually we created our own called Project Aslan, and we've got 18 partners from all over the world and about 35 engineers, and growing pretty quickly working on that. And that provides really low cost access to a self-driving software that has been validated for on-road use. And again, to Mark's point, it's all about low speed. It's about taking risk out of the equation and lowering the technology bar to an extent. So maintaining safety, but taking a lot of risk out of the equation. And Aslan does that. And that's proving to be really successful. The third part, and perhaps most applicable to this panel, is what does connected mean? What does the future of autonomy mean when it comes to a connected vehicle? And we see real parallels in things like the App Store, where we're starting to see lots of developments in things like fleet management and teleoperations that need cloud and quick systems, quick connectivity like 5G to be enabled on those vehicles at scale. We do think that 5G is an important component of that, and as such, we're taking part in a DCMS-funded project in Sunderland with Nissan and Sunderland Council and Newcastle University and others to convert a truck to take goods from one part of Nissan's car plant to their factory. And that really involves the integration of lots of different technologies. Again, low speed, involves integration of teleoperations, 5G, AWS, and as well as the autonomous systems that we built in that truck. So that's a real coming together of all the things we've done, along with some of the new concepts. And what we don't want to be is a technology waiting for a business model to happen. And I think when you start thinking like that, you have to get away from high-speed environments and think about cost. We're really trying to drive the cost down so that it doesn't make any sense anymore to employ drivers to do what machines can do. And I think that's still some way away. And I think part of the interesting conversation is to try and get people away from thinking about autonomy as a product and start thinking about autonomy as a service within the cities and environments we live and work in.
Yeah, there's a really interesting point, Mike, actually, about the sort of practicalities. Again, this is the theme that just keeps coming up through this session of how we actually, bring this from being sort of high level down to practical and usable, and companies able to make money out of it as well.
Exactly.
Paul.
Hello, everybody.
Did you do the classic mute thing?
I'm passionate about this topic for a number of different reasons. Firstly, quite a lot of the different sort of advisory hats I wear, are at this intersection. So the Robotics Growth Partnership I co-chair is all about smart machines, and these are smart machines. AI Council that's very much focused on the smartness, including the smartness that makes a smart machine. And a couple of ISCF programs, Future Flight and Robotics and AI in Extreme Environments. So very passionate about this topic. But whilst I was at Ocado, in terms of what's public, we were very much focused on autonomous vehicles. We did a trial several years ago back in partnership with Oxbotica in Greenwich, doing autonomous online delivery. And I think what's been very interesting in the pandemic is that there's been this shift from, probably what was at the forefront of autonomous vehicles at the start of the pandemic, which was all about sort of carrying people around, to really actually realizing that the importance was about focusing on delivery. And that is partly because of, trying to implement a low touch economy, but also because the safety case around autonomous delivery is a more attractive one, because obviously you still have to avoid hitting and injuring people, but at least in terms of what you're carrying, your cargo is arguably slightly less of a safety critical nature. I think the future of trying to build out autonomy is really about a whole different set of supporting technologies. So, digital twins and simulation, which is absolutely at the core of a lot of what I'm focused on, and indeed how that fits within this idea of a national digital twin program. That's going to be really, really important. And any of the companies who are doing things in autonomy are doing a huge amount of their learning in synthetic environments. But it's also about living labs, because as Mark was saying, there's a lot to learn. And if you're going to get this technology maturing, you have to do it in constrained environments that are realistic in terms of the representation of the real world, but where you can take, more risks, but very much still expose these embryonic smart machines to diverse challenges, and including having people involved. And that's why, digital twins and living labs need to be part of our kind of national fabric for innovation. Something I talk to government about a lot. If we're going to be successful at this, I feel very strongly that that there is a very strong focus on electrification and autonomy, and that's great, and those are important pieces of the puzzle. But frankly, even if we swapped all of these vehicles to be electric and autonomous tomorrow, it would do nothing really to move the dial in terms of the congestion on our streets and reducing the environmental footprint. Because what we've got to do is achieve orchestration and coordination of these vehicles. We've got to do that orchestration and coordination across sectors and indeed across competitors, because otherwise we'll have half-empty autonomous vehicles, electric or not, traveling around the streets, and that won't be a good outcome. Which is what leads to this concept that I've talked about a lot, which is the idea of building an internet of freight for the UK. So think of public cloud, but for moving not electrons around, but moving atoms around. And perhaps that's something we can come back to. It's a big subject, so can't really dive into it. But I think what the pandemic showed us when it struck was we need lots more smart machines, and we need to weave them into a fabric for a smart country. We need to use the UK as a country scale living lab, like others do, like Singapore and others, because if we do that, we will not only help implement a vision for a smart, prosperous, sustainable, resilient UK, but we will also create an amazing demonstrator for products and services that we can sell around the world. So we need to do that. And it is really across lots of different technologies. It's not just autonomous vehicles, it's drones, it's robots, and so we need to think of this as an ecosystem, a smart ecosystem for moving all sorts of atoms around across the whole supply chain. I'll stop there.
Paul, I think we will definitely come back to talk about the Internet of Freight, because I think it's such an interesting idea and what it would entail, everyone sharing information and working together. It's, really, interesting in a competitive field. Do start getting your questions in. I've not got any on my screen at the moment, and basically you've been brilliant all morning. We've had some fantastic questions and light questions, and the more it's liked, the more it goes to the top of the leaderboard and I ask it. So please get those questions in, unless it's my screen. I don't think it's a tech problem, but feel free to do that. First of all, I want to come back to Maya and just get a bit more detail about what you're talking about with this mixing of humans and robots, and how it seems to have stalled a bit at the moment, and perhaps misunderstandings. To get a bit more detail about, if you're not a robotics expert, what do you mean? How do humans and robots misunderstand each other? And what needs to happen for them to sort of start understanding each other? Do you literally mean when you pull up to a junction and there's a robotic car coming, you can't kind of wave it through or use the normal eye contact you would with another human being, and you need to teach the robots a way of doing that? Or what kinds of things do you mean?
So what has been introduced several times in those 5-minute introductions today was finding a business case for automated mobility. Understanding that we're talking about low speed automation, we're talking about automation specific constrained environments, and so on. So when I talk about interaction between a machine and a people, let's define a machine. A machine is can be any vehicle driven by a human being, a vehicle as we know them today, with some assistive technologies that help them be safer, operate safer in a certain environment. A machine can be a warehouse automation robot. A machine can also be a smart infrastructure CCTV camera in a connected vehicle scenario, or all the way up to level 4, level 5 autonomous systems. What they all have in common from our perspective, that we're first and paramount is safety, right? Make sure that systems are safe before they're launched, or in order to be launched, and to be adopted and be used by the public. Now, if we look at safety, we're looking at being able to reduce accident, prevent accidents, achieve Vision Zero goals, such as no pedestrian fatalities until I think 2041, or help reduce any type of collision involving essentially growing a number of vulnerable road users, from pedestrians to cyclists, no scooter users in the UK, and so on. We're also talking about efficiency. We're also talking about helping any level of machine with some perception, understanding of the environment, to be able to really assess whether at what level it's safe to progress at a certain speed, when it's time to brake, when it's time to really navigate around people. So efficiency is really, really important for the business case. If an automated vehicle has to stop every time it sees a group of people around them because it's unsure whether those people will cross their path, if people might create a risk, a potential hazard, then we see the system, the vehicle stopping. And as a result, it's it can't progress, it can't move ahead. So efficiency is a big problem. So when we talk about interaction, we're essentially focusing on safety and efficiency. On one hand, create systems that help a vehicle with a human driver, for instance, to be safer, make sure that we provide an advanced additional perception. So for instance, in a work with fleets specifically. And we're talking about making sure that we provide this additional perception. And perception for us means we have a nuanced understanding about what everyone in a street environment is doing and is likely to do, predicting what is likely to happen next. And with this information, help feed it back to a driver, for instance, to prevent accidents and make sure that it's done as much in advance as possible so that we can actually enhance the human perception. In a more automated scenario, like an autonomous vehicle, for instance, that may mean that we provide this advanced perception as an input to BRIC, to adaptive path planning, to create a more efficient navigation around people. And really it is around safety efficiency that then as a result creates trust, right? Creates trust, be it trust in people adopting, accepting technology, and then as a result, adoption rate. There's a lot of conversations happening at the moment around standardization, what levels of standards, what level of design domains have to be acceptable for automation to understand, to conquer, in order to essentially move to the next level. We've spoken about living labs, that I absolutely agree. Those are incredibly important in the level of in terms of really progressing technologies. But ultimately, the question is about when are those technologies going to be fit to really operate in the real world? And this is where, again, it's the safety element, but safety and mixing it with efficiency that will make it work.
Paul, we mentioned living labs there. You've mentioned them as well. Let's just quickly get on to living labs and digital twins. Now, what kind of impact can this technology have in terms of speeding things up?
So, you can do a huge amount of the kind of ideation, design, testing, and learning within synthetic environments. So high fidelity mathematical models, and obviously, as I've talked about in the past, Ocado and other companies I've been involved in make extensive use of that, but so do autonomy companies, because you've got to get a lot of miles on the clock, and think of getting these systems playing effectively the equivalent of car driving video games, but simulating environments, simulating the kind of threats and challenges that these systems will meet, including the one that Maya's just been talking about. But you get to a point where you reach the kind of the limit of really what you can model. It's really hard to model things like public adoption and trust and ethics and privacy. How are human beings going to respond to vehicles covered with sensors, including cameras, moving towards them? And it's not just about the vehicles, because it's also about the last 15 yards, and that's probably going to involve robots. So there's a lot of trust that needs to be developed, and we've got to get people used to the fact that these vehicles will be inevitably collecting a lot of information in order to try and navigate and localize themselves, but also to make sure that they do the right thing, so that they achieve the safety that we require. And so the living labs, a bit like the one that Ocado is building in Hertfordshire, but indeed that others have built around the UK, and it's really about creating this kind of realistic environment. But it's not a technology test bed. It's not about reproducible kind of testing. It's really about exposing these kind of technologies to a diversity of unpredictable challenges, which is often shorthand for humans, because humans are wonderfully good at creating diverse challenges that the people who write software don't expect. And of course, they are going to be either in the future the passengers or the customers, that are going to be on the receiving end, of these kind of technologies. So it's about doing real world experiments, learning by doing at scale. And we need these kind of living labs, not just for autonomous vehicles, but all sorts of problem cases, if we're going to implement these kind of technologies at a national scale. And just one other point I'd make, going back to Maya's point, I think there's a balance here between autonomy and orchestration. I mean, I think I absolutely agree with what Maya said, and that's kind of like the challenges that you hit when you get to kind of urban environments. We're surrounded with people and animals crossing roads and everything else. But there are more constrained environments, namely things like motorways, where in a way, in order to get the kind of the density of the traffic flow, you really want to turn motorways into kind of slotted conveyors that vehicles, both autonomous vehicles and conventional vehicles, are traveling on. When I travel down motorways and I see the sign saying this is a smart motorway, my immediate thought is, well, actually, it's not really a smart motorway. The kind of a really smart motorway is one that would, in a sense, implement that kind of slotted behavior, because I think that's how you'll get the density of movement. That's a bit like putting your vehicle on a train and taking it to Europe, but so think of almost like a virtual train that is where the connectivity between these vehicles allows us to achieve that kind of orchestration and which is important for safety, but it's also important for how close these vehicles can move to one another.
We're getting some really good questions in now, so thank you very much for that. We're going to come to some of these actually. So, Mike, why don't I throw this one at you? Can we expect autonomous vehicles on UK roads with current infrastructure, with slight modifications, very key to this session actually, or do we see a future of tunnels with cars and streets with people only, avoiding car to pedestrian interaction? So how do you see the future? Do you see it as, cars driving around where we are walking, or do you think that we're going to need to build very specific and probably quite expensive infrastructure to keep them away from people?
I think the challenge is consistency across environments, right? One of the, I'm not sure I enjoy talking about SAE levels and level 2, level 4. Level 4 is fully autonomous within a certain domain or a certain geographical location at least. Level 2 is when there's a full system supervisor. Someone will call that a driver. And the challenge is, when does a driver know that the system can work, and when does a driver know that the system's not going to work very well? So minor changes to infrastructure, no chance. That's kind of dreamland, and that's why we're kind of advocating just go slow. Because at slow speeds, it's very easy to avoid accidents. You just stop. And the things that Maya's doing, for instance, really help a vehicle understand where it needs to stop, for sure. And those kinds of technologies need to come into play. But it's unrealistic, I think, to expect the world to change its entire infrastructure in order to benefit from autonomy. So we need to find ways and technologies that allow us to do that in a commercially viable way with people around, in environments that are going to benefit people. And that's part of what we're trying to achieve, is how do you make this technology viable in an environment that exists already? Otherwise, it's simply not going to scale. It's simply not going to benefit people. And there's a lot of efforts, as has been said, in terms of what the standards and the validation needs to be in order to achieve that. There's a lot of work going on at the BSI, for instance, which I'm sure has been talked about today, around what it means to safely operate a low-speed vehicle. There's a new ISO coming out called ISO 22737, which actually gives a real guidance as to what the test will be to enable a safe, autonomous, low-speed vehicle to exist in an urban environment. So there's a lot of work going on in order to understand what that means. But no, I don't think changing entire infrastructure is practical, and minor changes just won't work.
Do you see that safety driver as a sort of huge barrier to getting towards a point where we can drive around in automated cars? It seems like a long way from a point where you don't have to have a highly trained person there. Yeah,
it's a huge issue as well, partly because of the language being used by some motor manufacturers. I won't pick on Tesla specifically, but it's a bit of a nightmare when they're testing what they call a fully autonomous system, which isn't a fully autonomous system, and they're putting their own customers in those vehicles as safety drivers, essentially. If you take a safety driver test with us, you're looking at safety engineer test. You're looking at a week's worth of training and examinations, and someone who has a full understanding of the system that goes into those vehicles. And the ones that we operate are operating at virtually the same level as a Tesla would be, or a very advanced ADAS system. And so if the safety driver aspect is pretty critical, because whereas to really test on the road, you need someone who's a full engineer, not a member of an untrained public. So there's a danger, I think, that the language being used is a massive barrier to the adoption of the technology, because it's not being done in a safe way. Mark, do you fundamentally agree with that? You were hinting at it earlier. Perhaps we've got a bit seduced with the idea of driving around in cars, and actually we're not focusing on the bits that are going to make money and develop the technology in the near future.
Yeah, I think I would broadly agree with what Mike said. And in fact, I think in terms of, do we expect fundamental large infrastructure changes? Well, I'd say, well, where's the business case to do that? There are other competing strategic priorities, for example, around meeting zero carbon targets. So I think very much that we're looking for the technology to work in the environment that we've got today. And the task is to find those business cases where it really makes a difference. And I think, by the way, there's probably plenty of them. But perhaps it's time to try and focus on that end of the challenge, rather than the vision we might have spent a little bit too much time indulging ourselves with, where we're all sat in the back of a car sleeping while we get taken to work. I think, sort of building on that, I was taken by the point that Paul was making earlier around, the application of electric autonomous vehicles in itself doesn't do anything, or it achieves very little, and it really is that orchestration point that is very, very important. It's technically something that, from a technical perspective, I think you can see your way through it, but it's commercially incredibly difficult to do. And what that really points towards, I think, is having a very clear vision of where we want to be in the decades to come, and working back from that so that we can make incremental changes together.
Just very, very quickly, who provides that vision? Is it people like you? Is it the government? Where does it come from?
Well, I think we certainly would have a strong view on that, but I think there's room also for government to have a strong voice in that, and to clearly state its ambition. And to some extent, things like the industrial strategy start to paint that picture. But I think there's a role for more direction there.
Yeah, you don't think necessarily private companies would come in, and because we've all talked about Tesla this morning, so it sort of comes out of nowhere and suddenly they're on the roads. You don't think necessarily it's going to come from big car manufacturers or tech companies?
I think it's really difficult to say. I think it could come from any number of these places, and we shouldn't think about this as being a problem that is only going to be tackled in one particular way or by one particular type of organisation. I think that the job is to create the environment in which whatever are the most appropriate solutions for our economy can emerge.
Right, we're going to get to some people's questions now, because they've been kind enough to send them in. So this, good one for you, I think, Maya. You can take this one on. Given the impact that autonomous systems will have on society, do we have the moral responsibility of, it's just gone to higher up in the, do we have the moral responsibility of minimizing the impact on the human drivers and maybe relocating them to different roles?
Oh, that's a difficult question, because it involves morals, and B, it also works on the assumption that the human driver will be replaced in the near term, which I don't think, I would agree, because the technology is just not looking that way. I think the responsibility that we have is to make sure that everyone is as safe or safeguarded as much as possible. And we do expect that for a long time there will be human-driven vehicles out there, and in fact there will be, automated technologies will be used in order to enhance the view, enhance the safety, enhance the abilities, if you will, of the human driver. So in that sense, I think we have the moral responsibility of making sure that any system is as safe as possible, and making sure that, where a human driver would be prone to accidents, whether it's drowsiness, distraction, and so on, that we make sure to implement artificial intelligence systems that help prevent these. And I think great examples are driver monitoring systems. Great examples are a type of enhancing assistive technologies. So I would always view it from the perspective of using technology to enhance abilities, other than really replacing anyone. And I think this is also where when we look at automation, we look at use cases of automation, when we look at how can we make it to the best societal use. If we look at it from that perspective, enhancing current use case, enhancing current infrastructure, I think it can come to good use.
I think you raised a really interesting point there, and I'm going to throw this open to all of you, so we'll do our best for not to talk across each other. A couple of years ago, I went to Gothenburg and went in Volvo's automated car, and they had a system. They were very specifically explaining it to me that had a computer backing up a computer backing up a computer and so on. So the human would never have to step in. And they were going to experiment with that on commuter roads in Gothenburg, and they were going to do it in the UK. I don't think they are now. Where are we at with that, all of you? Because I haven't seen much on that in sort of recent years. To having computers make sure that humans never have to step in. Do you think that's realistic, or will there always be a point where a human will have to step in?
Well, the point is that it's you can add as many levels of redundancy as you like, but ultimately it's going to be down to the sophistication of the AI and machine learning models that are in any way trying to replicate, you know, what a human driver would do. So it's about the software and the sensing rather than, you know, the amount of redundancy in terms of the compute. But of course, you know, that model of having, you know, like 3 gyros on an aircraft to make sure that if 2 of them disagree, you've got 1 to arbitrate. It's an important point. But I think there's going back to the morals, I think there's a really fundamentally important part, a decision that we have to take in going on this journey, which I think history would suggest that we haven't learnt yet, which is we can't view, you know, this kind of intelligence, I put that in quotes, as something that somehow it has to achieve a kind of a benchmark that is somehow separate from human, you know, activity. Because the fact is, human drivers kill and injure a huge number of people every single day, thousands, I don't know how what the number is, around the world every day. So the fact is, you know, that's what we have to compare these systems with. And we have to not get hysterical, because the fact is, this emergent technology, you know, it's almost, well, it is inevitable. They will, you know, there will be accidents and people will be injured and even killed. But the fact is, we have to compare that with what, as I say, human-driven vehicles are doing, and see that as the benchmark. And of course, that isn't just about autonomous vehicles. You'd say the same about a robotic, you know, surgeon, or you know, a robotic control system, or a system controlling a smart aircraft, or whatever it is. So, you know, we've got to be up for that, you know, that kind of journey that we're going to go on as this technology matures.
Okay, Mike, I'm going to throw this one at you. It's one of the more popular questions we've had in. Oh God, now I've lost it. Hang on a sec. It was effectively, I'll paraphrase it. It was how important is the move from 4G to 5G in terms of getting this, you know, technology up and running and working properly?
First of all, I'm going to address the last question, if I may. I think it's absolutely vital that we aim towards 0 accidents with automated machine. If you think back to what happened with the accident that Uber had when they were out testing a unfortunately unreliable and badly designed system for autonomous vehicles, and it killed somebody, and it put our industry back by a considerable amount of time. I think society are very unforgiving of machines that kill people, and we need to bear that in mind. You know, I would advocate that if the machine has to operate at a high level of automation with just a computer, doesn't matter how many computers, you've got to expect those computers to fail. That's why cars use ECUs. They don't use CPUs for their fundamental safety systems. And you know, we've got to be very, very conscious of that fact. So I would say, you know, for the next considerable amount of time, full automation can only happen at very low speeds, where you can simply stop a vehicle and not kill anybody, and that's pretty essential. 4G to 5G. So we've been looking at use cases around teleoperation or remote operation of vehicles in industrial settings, as well as on the road. It seems like actually 4G works in most cases. What will not work is at scale. 4G will fail because of its bandwidth capabilities. So at scale, what you'll need the same kind of speeds that 4G can normally enable in local situations, but at higher bandwidths. And that means a lot of data. If you consider the amount of data that needs to come off a car to be teleoperated, we're looking at camera data primarily as as the critical point. You need round trip latencies of perhaps less than 10 milliseconds, which is hard to achieve, but not impossible at 4G. I've talked to people who have done that quite comfortably at 4G. 5G obviously enables it to be quicker, but it provides a bandwidth that maybe you can have 20 of these kind of vehicles operating within the same environment. So that seems to be what we've seen as the most critical element.
Mark, I've got a question here. What's the biggest challenge you've come across for the autonomous system integrating into society?
That's a big question, isn't it? You know, in many senses, I think we're back to that morals question that we were talking about a few seconds ago. And, you know, are we up for it? There is this human behavioural challenge around the rational versus the irrational. And I think if you look at the studies of, you know, if people are asked, what kind of safety would you find acceptable for an autonomous road vehicle, they'll typically say, well, I'd expect it to be 10 times better than a human driver before I'd get in it. Which, if you think about it, is really irrational, because surely a vehicle that was twice as safe as a human driver would be a fantastic thing for society. But, you know, humans are irrational things, aren't they? So in some ways, I think actually this just reinforces the need for the living lab type experimentation at scale, because, you know, for us to move from where we are today to the yes, we're up for it, is going to require exposure to these systems and greater understanding and acceptance of these systems on a much bigger scale. But fundamentally, they're coming. So they're not set of technologies we can put back in a box. And, you know, I've had first-hand experience of this in the drone sector. You know, 15 years ago, we, as a community, we were thinking about the hypothetical ways we could use that technology and what regulatory environment we might need to make that safe. And it didn't really proceed rapidly until the point where you could, you know, walk down the shops, go into Currys or any other electrical store, and buy one of these things off the shelf. And then you know, once the technology is out there and you can't put it away, then it really forces a change. You know, I think Living Labs is a great way for us to get ahead of that.
Maya, what's your take on that? With the big barriers? Is it perception? Is it, you know, well, I was talking to Mike actually before these sessions, and he said cost is going to be one of the big barriers. But do you think the biggest thing to overcome is people's perception?
Well, perception is a big one. I think the actual use cases, that's another really big one. But one thing I wanted to add to one of the previous questions also ties into this one is trust in artificial intelligence, and really us starting to think or rethinking how we build certain systems. So for instance, I'm a big advocate of explainable AI, right? So building technology, particularly if we're taking safety critical decisions that might impact, you know, a decision that let's say an automated vehicle or automated machine may do, to make sure that the system is set up in a way that we can understand why it took a certain decision. So really probably against a black box approach. So an example of black box approach would mean data comes in, decision comes out, but we don't know why, why a neural network did what it did. That's a terribly difficult when it comes to functional safety, basically making sure that automation is road safe and road proof, but also in terms of integration, but also trust. And building, modularity, explainable AI. There's a lot of those, I think, turned into trends now, which I really welcome. And in the way we develop technology, that I think will, are huge barriers today, but will help overcome some of these, particularly in the public perception. Just quickly on the other point, which is the use cases. I think that particularly in the earlier days of automation, of let's call it almost peak hype of automated technologies, we were not really considering about what the actual application would be of those technologies. Like Paul, you said, just having an automated vehicle out there, it's not necessarily good for anyone, not good for society, but how are we actually implementing those? And I do see how now there's much more discourse, much more communications around that, making sure that you know, if when it comes to carrying people, transporting people, it's about public transportation. There's a lot of elements in the train sector, in the tram sector, in the bus sector, in the public transportation sector. But at the same time, you know, application across the supply chain, from, you know, the warehouse to whoever receives the delivery recipient. So I think perception of artificial intelligence, but also how we're actually putting this into good and proper use, are actually big barriers, and they lead directly into the monetary, into the business case and the cost discussions.
Now, Paul, I said we'd bring the Internet of Freight in. It's a really interesting idea. Could you explain briefly what you mean by it, and then I'll get the others' take on whether they think it could ever happen or not?
So, I mean, the best analogy of it that I have is public cloud, and, you know, everybody on this call will be using it whether they know it or not, in terms of where they store their data and many other services they consume. And, you know, the reason why public cloud has thrived is because of common standards, common interfaces, common middleware, the fact that it's allowed people to just concentrate on where they add value as their businesses, rather than build their own infrastructure. And it's you know, it's all about moving, obviously, you know, information and compute around, you know, at scale. But you could do the same, you know, for moving atoms around. You know, you need a common, you know, a common digital, if you like, highway for connecting the different use cases. You know, if you're dropping off food at a hospital, you know, there might be a bag of plasma or you know, COVID samples that need picking up. But those worlds will never find each other at the moment, and they must in the future, because that's how we will get, you know, less vehicles on the road, is if we're making sure that they're, you know, they're more full, and that you don't have, you know, 10 vans visiting somebody's house when you might be able to, with better coordination, you know, have less vans doing that, and obviously on the roads before that. So it's about the digital coordination, and using things like digital twins to obviously optimize those models, and machine learning, and of course, but it's also about new kinds of physical ways of moving atoms around. So whether it be, I don't know, pipes under the ground, or virtual conveyors created with autonomous vehicles, or, you know, swarms of drones in the air, the point is, you know, it's the physical and the digital that we need to optimize. And it's also needed, regardless whether you want to do automation or electrification. This is not going to be an overnight switch. So in the same way that when you try and move your systems to the cloud, as many of us did many years ago, you know, you have to manage that process of living with both, you know, the cloud-based world and your kind of on your own infrastructure. And that's a managed process. And the way you do that is you wrap your legacy infrastructure in something that makes it look like the new stuff. And then you can treat everything as the new stuff, even if some of it under the surface is still old. Well, we're going to have to do that. So we need to wrap, if you like, existing vehicles and existing kind of logistics to make it look like this kind of Internet of Freight. And then we can have a smooth transition from one to the other.
Mike, I want to get your views on this, because I guess the bigger question is, it's going to involve lots of people working together, collaborating, sharing data. They might be competitors with each other. What's your sort of personal experience of how well the different parts of the puzzle are working together at the moment, and whether there is a willingness to pull together kind of for the greater good, as it were?
Generally, there's no willingness whatsoever to pull together for the greater good unless it's mandated. I think we've seen that a lot in this industry. Lots of companies building the same kinds of technologies in parallel, and all they do is push up the wages of engineers, which makes it a nightmare for me. I think the Internet of Freight idea it's interesting. I think there's a lot of challenges around mandating the use of technology at a corporate level. You have a problem there in terms of stifling innovation, perhaps amongst companies that don't have the capability to join in the party. That'll be one of my worries. I think when it comes to that kind of cloud-based system, they're essential for the future, because if I think of the humanizing autonomy application, for instance, if I'm running a fleet of autonomous vehicles, what I don't want to have to do is to hardwire that bit of tech into each of one of those vehicles one at a time. You need to be able to put that technology in the cloud and have the vehicles adapt to that technology in one go. And I think that's where the use of a cloud, a connected cloud, really comes to its own. And it's no different really than running a network of mobile phones. You need the 5G connection, but more than that, you need the data connection that allows the applications to run on the system. Now, some of those applications will be fantastic, and some will eventually die off, and you'll be replacing them with other ones. And I'm not sure how much we can mandate which ones of those should work and which ones of those shouldn't. That's going to have to be a commercial decision made by the markets. But the idea of the Internet of Freight, or at least a connected cloud system that has some standardization and some standards and some validation, makes sense.
Mark, what's your take on it? And I'll bring in a question here as well, because I guess as a catapult, part of your role is to build teams and to get everyone sort of maximizing what the UK makes from all of this. And someone's put in as well, what country is the UK's biggest competition in the race to grab these billions of pounds potentially? So again, how good do you think we are at the moment at collaborating? And is anyone in the world a benchmark for how to do it? Is anyone getting ahead of us, or are we doing well?
Well, I think there's lots of different aspects to innovation, and actually collaboration is something that the UK is certainly measured as doing very well. And I think, my experience would be actually we do extremely well. Clearly, there are other places around the world that are in a different position for other things that may affect innovation. For example, access to venture capital. So, I think there are certainly global competitors. There's strengths and weaknesses. The UK, I think it's well known that it's got an excellent science base. It's well known for its collaborative environment. We are less good at translational research, and that's really what was behind my talking about the extra investment in R&D. Let's focus it on the D bit rather than the R. But going back to the question around sort of the Internet of Freight. It strikes me that that's an idea that is eminently technically possible, not without its challenges, but you can see how that can be arrived at. Again, it's something that you need to set a vision around. The market on its own will not deliver that, I believe. Therefore, there's a market failure and there is an intervention needed. Now, that doesn't have to be government stepping in and mandating lots of things. What we really need to do is to work out what are the key touch points. And maybe that could be information about a parcel journey or arrival departure times, and setting on what is the minimum set of common interfaces, and then letting the market evolve to deliver that solution. Because that future vision is full of economic opportunities. It's just they're different ones to the ones that organisations are delivering against right now.
Mar, I just want to bring you in at the end here. What do you think is the most important thing to get right in terms of the messaging for people to accept this technology, and also for companies to sort of realize what is out there, the possibilities for them? How important is it to get that message right in places like the media, for example? And are we doing it very well at the moment?
Well, I think it's incredibly important, but we need to look at it at different levels or tiers almost. There's the general awareness / fear of artificial intelligence, addressing that for the general public, and making people understand that there's absolutely applications that are coming. They're already in place that take an active role in shaping, again, back to safety, kind of a proactive role in almost like improving the status quo while building out a roadmap of what is coming next. So there is a level of improving the status quo. I think that's incredibly important. It's not all complete disruption. So I think that's one. When it comes to businesses, then I think it's about helping businesses understand how they can then create a ROI, how they can create their commercial gains by implementing these technologies. And there it's important about making use cases clear. really showcasing the benefits, whether again looking at the automation, looking at what are the benefits of operating more quickly, being able to adapt to a certain environment more quickly, enhancing safety for certain, whether it's a driver safety, whether it's passenger safety, and so on. I think it's really around the macro messaging, but then the really precise, whether we're addressing the public or whether we're addressing the businesses that implement those technologies.
Well, guys, thank you very much. It's been lovely to tap into your various expertise and hear your views on things. Thank you for all the questions that have come in as well. I'm sorry we didn't get to some of them. Hopefully we answered some of them for you. And don't forget, you can connect up as well on the platform and ask people yourself. A little bit of housekeeping before we end the session. So you can use this opportunity, it's lunch, to visit the exhibitors, connect with others via the one-to-one text chat or video calls by clicking on the individual's profile. And please do come back at 2 o'clock when we'll have our last session of the day. And it's going to be all about what needs to happen next in terms of the law, for example, and in terms of safety, again, to make sure that we're sort of optimizing the opportunities that autonomy potentially can bring. But for now, thank you very much to my panel, and we'll see you after lunch.